Welcome back to the second part of graphing calculator practice, and let's just go ahead and read a couple of these things. At times you want to find the intersection between two or more functions. Oh yes, especially for calculus. You may want to find the maximum values of each function as well. And let's go use the graphing calculator to do both. So what I've done is I brought back an Algebra 2, Algebra 1 problem that asks for a maximization of a specific area. So Maria has 25 feet of fencing with which to make a rectangular garden, so that's what she wants to make. She will use her house as one side of the garden and the fence for the other three sides. What dimension should she use to make a garden with the largest area? And the second question is, if she wants the total area of the garden to be 40 square feet, at what length should the garden be? Let me just make this paper in half, sort of. You don't have to, of course. Okay. But let's go ahead and maybe my first step that I want to give you guys, and I'm answering part A over here, is maybe label and draw. I mean, is it needed? Of course not at this point, but especially for visual learners like myself, you just kind of want to see what this is looking like. Then that way you can get the equation based on that. So here's one side of the house, and because on the second sentence she said she will use her house as one of the sides of the garden, as one side of the garden. So that means that the other three sides will be using the fence that she has, I guess, purchased. Okay. All right. We don't know how long this is because we are not told. And so because this is an unknown, let's make that as your x. And because this is a rectangle, let's also make this as your other x. We do know that she's going to be using 25 feet of fencing. So to label this part over here, we've already used up two x's. So we're going to have to do a subtraction of 25 minus 2x. And that will be that third side. And we don't have to make an equation over here because we're not using a fence in this part. And that's just part of the house. Okay, so we got that label and draw out of the way. Then our step 2 is to make some sort of main equation. And we're going to figure out what main equation to make based on that question. What dimension should she use to make a garden with the largest area? Okay, since we are wanting an area, let's go make an area. And this shape is a rectangle, so the area of a rectangle, our main equation is going to be length times width. That is an L. Apologies. All right, let's go substitute now. I'm going to make this into a function a of x because we had chosen x for this. You could have also had used another variable if you had wanted to. And let's go ahead and substitute. Your length could be x, or shoot, I just already wrote 25 minus 2x is fine. X, these are interchangeable, of course. Let's do the distribution. It's going to be 25 minus 2x squared. Okay. You're going to see a little splice on this video. It just jumped like, whoa, what happened? Because I made a mistake. I'm going to let you know I made a mistake twice. I had to refilm this twice. And so this is going to be oh my gosh. I'll tell you guys about the mistakes a little bit later. After the distribution, it'll be 25x minus 2x squared. Okay. Boy, even up until today, I'm still making mistakes. But anyway, the video should be fixed, and let's go ahead. And that's why I've it looks like I've already written down everything. That was because that was from the mistake earlier. But anyway, these are not mistakes. Once you have these, step 4 is you're going to plug this into the y equals function on the graphing calculator. And then I can wait for you guys to copy this one down. But it's a video, so it's totally fine. Okay, so let's go ahead and plug this in. And you can totally erase these parts over here, but sometimes you may not want to erase everything because you can input, there's certain problems where you'll need 2 or 3 functions that you need to work with. So you can leave one in y1, leave another one in y2, and leave another one in y3. Again, just be very, very careful when you're trying to evaluate. Make sure if you're grabbing a function, you know where it is, So since I put the quadratic on the y2, I got to make sure it's in the y2. Anyway, I cleared off everything. So let's put 25x. That was my mistake from the previous video. So 25x, again, x is by the alpha, minus 2x squared. And my first mistake from the first time around, forgot to put this 2 here. God, I have to film this twice. All right. Before I move on, I just need to make sure everything is put in correctly. Okay, everything looks like it's put in correctly. Let's go hit graph right now and see what happens. Okay. The reason why it's doing that right now is because I'm in standard window, and for standard windows, the zoom is going to be 6 over here. The standard window is from -10 to 10, -10 to 10 for your x's and y's. Okay, so that's why it's only making us look at this window view. But I really don't see a parabola because it looks like a straight line. Okay, so one of our best friends that we're going to use this school year is zoom fit 0, and that's going to be in the zoom function. So let's go ahead and hit zoom. You can either hit 0 already, or if you're like me and you want to kind of find it just to make sure, then you go ahead, hit the up arrow and hit zoom fit. Otherwise, just hit the 0 and hit enter. It will do the same thing. And let's go see what that looks like. This graph is okay. It's totally fine because our point is we want to see the largest area. The largest area is going to be our maximum height over here. Okay, so you don't have to go and change it. I think this is okay enough. But if you're like me and you kind of want to see more of a parabola, you can go ahead and change the window settings that fits your needs. Okay, so maybe for me, I think I want more x values, and then that way I can see the parabola increase and then decrease. Okay, and even though this is okay too, I think maybe I just kind of want more space up over here, than that way I know for sure this is the maximum, even though the calculator will calculate it. It's really up to you. It really depends on your needs, but I just want to change it. Let's go to the window settings. Maybe I want more x values. I'll go 25. Maybe I want more y maximum values. So 78, maybe 100, I guess. Okay, let's go see that one here. Yeah. This looks better for me, visually for me, because, we always draw parabolas this way. But again, the previous setting was totally fine too as well. Okay. All right. Now we can finally use the max button, and that's going to be at second trace and 4. So let's go ahead and do that right now. So it's going to be second trace, and then we have our maximum. And I think we'll be using a lot of these values a lot, even for number 6 and 7 as well, but that'll be a little bit later. So let's go hit maximum, hit enter, please. Okay. What's going to happen is it's going to ask you for a left bound, a right bound, and some sort of guess. So the first two, you want to make a boundary so that, here, I'll just show you. So maybe the left bound, maybe we'll make it over here. And maybe the right bound, we'll make it over here. Okay, then that way you're telling the calculator you only want the calculator to just kind of see from between these two x values over here. Okay, so here's the boundary. Don't look anywhere past that. Okay, then your guess. Remember, you want to find the highest y value. So let's take a look at your y values right now. 68, 70, 72, 74, 75, 76, 77, 77, 78, 78. Oh, and then we went back down. Okay, so maybe either this one or this one. Maybe this one here. Let's just pick that. That looks like the highest from our selection of choices. Let's go ahead and hit enter on this one over here. All right. 6.249. So we could either grab that, or we could even round it up. It's totally fine, but we'll definitely grab the y value. That's for sure. Okay. So again, from over here, you're going to select left bound, right bound, and then guess. So the left bound and right bound, again, just means that you just want the calculator to specifically look at a specific place and not anywhere else. Anyway, I think we already found our answer. I hope. Okay. So I'm just going to write this in coordinate form, 6.249 and then 78.125. I think on some of your calculators, like this is so close to 6.250. Again, I'm not too sure what calculators you guys are using. I think for some of you guys, some of you guys might have 6.250, and I think that's fine. Okay. Again, what do they represent? Oh, I mean, I already know the answer already. It's supposed to be 6.250. It's just so close for that one. Okay, you know what? I'm going to change this to 6.250 just for today's purposes, okay? But 6.249 will also be okay. Let's just round this one up over here like this. Okay. The question was, what dimensions should she use to make the garden with the largest area? So again, this is your x and this is your a of x. So here's your area, and then your x is going to be one of those lengths over here. So let's go ahead and choose that right now. So the largest area will be 78.125. L is equal to 25 minus 2x. So the width is going to be 6.250. And then we're just going to plug this in over here. Second quit. 25 minus 2, 6.250. Okay, so 12.5. Okay, so your dimensions are going to be length is equal to 12.5 feet. And then your width is going to be 6.250 feet. Okay. All right, we are not done yet. So that is where we can use our max, second trace max, to figure out the maximum value, and that will help us out with that. Okay, and this will not be the last time we're going to use this. We'll be using it throughout the course. Let's now answer B. If she wants the total area of the garden to be 40 square feet, at what lengths should the garden be? So what's going to happen is we're going to plug in y2 is equal to 40 in the y equals function. Okay. So let's go ahead and do that. Let's leave this on the y1. On the y2, let's hit 40, and then now let's go hit graph. Okay, so hit graph. Okay, so it looks like we have a couple options. So what we want to do is we want to find those intersections right over here. Okay, so to see for the intersections, we're going to do second trace again. And then we're going to hit 5. Okay, so let's go ahead and do that right now. So we're going to go second trace, and then it is going to be 5 intersect. So you probably have seen that before when you guys were selecting for the maximum. So let's go hit enter over here. Okay, so now first curve, let's go ahead and do that. So there's 2 intersections. We're going to grab both of them. Okay, so let's start with the first intersection first. So just kind of guesstimate. This one will not ask for a left bound or a right bound, but rather on the first curve, where do you see the intersection? So that's what it's trying to say. So just really just approximate where that could be. Now on the second curve was the line that we inputted. Where is that at? Okay, so you're really trying to pinpoint where that intersection is, bam, and then just kind of make the guess. Okay, so your first intersection will be at x equals 1.883. Okay, so x is equal to 1.883 feet. This is our width. Okay, so here's our first answer. I wanted to make our first answer and second answer, but I don't want to confuse it with the numbering the steps over here. Okay, so, and then let's go ahead and find a second answer because there's 2 answers over here. All right, let's try again, second trace and then intersect. Okay, so we'll have to grab the other intersection. So the first curve, where is that at? Where is that intersection? Well, here, I guess approximately over here. Second curve, where is that intersection? So probably over here. And then guesstimate, we'll put this in the middle. So 10.616 will be that. Okay, so 10.616 feet. So that's going to be your width. Now this is just all calculation based. Okay, the question was asking at what lengths should the garden be. So if the width is going to be that, what's going to happen now is we're going to take 25 minus 2x, 1.883, and then we're going to figure out the length for that one. Quit 25 minus 2, 1.883. Okay, 21.234. Okay, and then after that, for this one here, I see my history, so I'm just going to go back down, and I'm just going to delete this. 10.616, and then this is 3.768. Okay. Okay, so you have two answers. You could either have a 1.883 feet by 21.234 feet, so that's one answer, or you could have a 10.616 feet by 3.768 feet. When you multiply these two, or when you multiply these two, you should get roughly 40 square feet of what the question is trying to ask for the total area of the garden. Okay. I mean, we can check it out. This is good. Yeah, you can check it out just in case, 10.616 times 3.768. Yeah, this is already roughly around 41.883 times 21.234, and it's a little bit over, but you know what? Oh, because 883 times 21.234. Yeah, close enough, I guess. Yeah, we can just round that up. Okay. I think this is enough information for you guys to do the last problems. Thanks so much, you guys.